Welcome back. In our last sessions, we were discussing about use of binomial uncertainty in our network design decisions. And in the last session, we discussed in detail about the use of decision tree for the purpose of evaluation of uncertainties in the future decisions. Now, we have already gone through the representation of uncertainty, we have already gone through the concepts of time value of money, and now in the last session we were discussing that what are the important things we should keep into the mind when we are going for a decision tree model, and we discussed that we need to have the period, we need to have the duration of each period, then we need to find that what are the underlying factors for which we are evaluating the uncertainty, then we need to represent the factor of uncertainty for all these types of underlying factor, then we also need to know the time value of money, and for that purpose we require some kind of discounting rate, then we also need to have what is the transition probability from one state to another state, and then we start calculating from period T, the last period, to period 0 from where we have started the building of this decision tree. So, all these things in a very detailed manner we discussed in our last session. Then we came to a particular specific example about deciding the warehousing situation, that we have alternatives where we can take the long term lease decision and we can take the spot market also. There are certain issues related to long term lease and spot market. Spot market is currently costlier, but there may be fluctuations with respect to price of the spot market, and in future the prices of spot market can go down. Then there is a situation of demand also. Today there is a demand, and according to that demand I take lease space, but it is quite possible that tomorrow demand may go down, and in that case when demand can go down, I have some kind of unused space in my warehouse. So, that is also extra cost. So, all these things we discussed. Now, coming very specific, so there are three possibilities considering all those situations which we discussed in the last session and in the previous slide as well. We have three options available to this company. These options are: get all warehousing space from the spot market as required. So, today you require 60 square feet, so take that much. Tomorrow you require 100 square feet, you take that much. Then you require 90 square feet, leave some 10 square feet and take only 90 square feet. So, that type of flexibility is there in this first option. The second option, that you sign a contract for 3 years and it is a fixed amount of warehouse space and get additional requirements from the spot market. So, you have taken, let us say, some 100 square feet area from the lease agreement, and if demand exceeds beyond that, so the additional requirement can be fulfilled from the spot market at whatever price it may be available at that period. And the third is sign a flexible lease, that you have taken a minimum amount of fixed area, and then you have some kind of variable uses of warehouse space up to a limit and additional requirement from the spot market. So, this is taking the advantage of the spot market condition as well as for the lease condition. You can have this kind of flexible, where for some space, maybe for 60 square feet you have this rate of uses, and beyond that you have some other rate of uses, and then there is a upper limit of the availability of the space in this agreement. And then even you go beyond that, if demand increases beyond that, the additional requirement can be fulfilled from the spot market. So, it takes the case of both spot as well as your lease agreement. Now, coming to some specific data. So the data says you require 1000 square feet of warehouse space for 1000 units. 1 unit takes 1 square feet. So for 1000 units you take 1000 square feet. See, current demand is 100,000 units per year. That is the current level of the demand. The binomial uncertainty is demand can go up by 20% with a probability of 0.5, and demand can also decrease by 20% with a probability of 1 minus p, that is again 50%. So chances of increasing and decreasing are same. Demand can increase same. Here we are taking the same values, 20% for the increase and 20% for the decrease. But in reality it can be different also. It is possible that the chances that demand can increase by 30% is 50% and demand can decrease by 10% is 50%. So that type of data is also there. It can also be modified that you have same value of U and D but different probabilities. The demand can go up by 20% with a probability of 60% and demand can decrease by a factor of 20% with a probability of 40%. So all these combinations are possible. Here just for the sake of simplicity you can say that this simple data is taken where demand u, small u, if you remember we introduced this term small u and small d in our last sessions. So that small u and small d, these are same. Small u becomes, in this case the value of small u becomes 1.20 and value of small d becomes 0.80, and the probability for both these things are 50% and 50%, though in reality it can be different also. The u can have a probability of 60%, it can have a probability of 40% and all other alternative combinations are possible. So as long as you have p and 1 minus p, so you can have variety of cases. Then lease price is given to us is that $1 per square feet per year, that is the lease price. If I go for lease agreement, so I will be charged at this rate. The spot market price currently is $1.2 per square feet per year, that is the spot market price. But there can be a uncertainty in spot market price also, and spot market price can also go up or down by a factor of 10%. So this U and D is for the demand, this U and D for demand, and there will be another U and D that is 1.10 and D is 0.90. This is for spot market prices. So you have two U and D, one is, and it's a matter of chance that for both these the probabilities are 50% again. So spot market prices can go up by 1.10, the probability is 50%, can decrease by a factor of 0.90, probability is 50%. And the revenue is from these units which you are storing in your warehouse $1.22 per unit, and for determining the present value of the future cash flows the discount rate is 10%. So that is the discount rate, K is discount rate, so that is 10%. Now let us see the development of decision tree for this set of data. So it is good if to understand this development of decision tree, we keep this data readily available on one side of our notebook somewhere. You can note down this data, and with the help of this data we will see that how we will develop the, or what we do, we develop this decision tree on the board, and then finally we will see that whether our decision tree looks like the decision tree which is there in the next slide. So, let us see how to develop the decision tree with this data, and I expect that with that you will also be able to develop decision trees on your own. First is the time T0, this is the period 0, where you have some demand and the price of the spot market. So, initially the current demand is, let us say, 100,000 units. So, for the sake of simplicity I am simply writing the 100, and it is into D is in units. So, you are clear that 3 zeros are more after this 100, and the initial price of the spot market is $1.2 per square feet per year. So, that is the initial price, that is 1.20. Now, we move to period 1. In period 1, what are the different possibilities? One possibility is that demand increases, one possibility is that demand increases and price also increases. So, demand is increasing, let me give you this with the help of plus plus. Demand is increasing and price is also increasing, both these things are having the positive things. So, the factor of U for demand is 1.20, and so this demand will become 120, and price for that factor is 1.10. So, price will become 1.20 into 1.1, so 1.32. So, you can see that this is the first case, that in period 1 from here you are moving to this place, that your demand is becoming 120 and price is becoming 132. The next is second case, where your demand can increase. Demand is increasing, but price is decreasing. Price is decreasing. So, demand is increasing, so demand becomes 120, but initial price is 1.20 and U is 0.90 for price. So, it becomes 1.20 into 9, so it remains 1.08. That is the another state, that D becomes 120 and price becomes 1.08. Then another possibility is, now demand can decrease and price can increase. Demand can decrease and price can increase. So, demand is decreasing by a factor of D, and D is 0.80 we wrote initially. So, D becomes 0.80 and P is increasing, P is plus, so P becomes 1.32. And similarly, another possibility is that demand is decreasing and price is also decreasing, both negative. So, in that case D becomes 80 and price becomes 1.08. So, these are the 4 possible states two states where demand is increasing, two states where demand is decreasing, two states where price is increasing, and two states where price is decreasing. So, in all these four states are possible, and since the price and demand, these two things are independent of each other, these two things are independent of each other, not affecting each other. So, therefore, the probabilities now we need to assign, if you go back to our earlier slide, that we need to assign the transition probabilities also, this is step number 5. So, now we will assign the transition probabilities, that the probability of increasing the price is 0.5, probability of increasing the demand is also 0.5. So, the transition probability here is 0.25, and so on for all other decisions also, all other states which we are getting, for all these different states the transition probabilities are 0.25, 0.25, 0.25 each. So, you get the complete set of 4 states at time period 1. Now, we need to go further because we are considering for 3 years. So, now this is the next year decisions. From here you can have another 4 possibilities, and these possibilities are same. Your demand can increase, demand can increase, there are 2 possibilities. Here price is decreasing, here price is increasing. Then demand can decrease, 2 possibilities, and in these 2 possibilities again price can decrease and price can increase. So, further you have 4 possibilities, but these 4 possibilities will be evaluated from this state now. So, if demand is increasing, let us say if demand is increasing, so here it is 120, demand increase factor is 1.2, so it may become 144. Here also it can become 144. When demand is decreasing by a factor of 80.80, so demand can become 0.80 multiplied by 120, that is 96. So, you should remember that I should write here U for D is 1.20, small d for D is 0.80, U for price is 1.10 and D for price is 0.90. So, similarly, when my price is changing, when I am having these 2 values where price is increasing, so 1.32 multiplied by U, that is 1.1. So, this value will come here 1.32 into 1.1, 1.32 into 1.1, and when price is decreasing, this is here price equals to 1.32 multiplied by 0.90 and 1.32 multiplied by 0.90. And again we need to have the transition probabilities. Chances of increasing the demand 50%, chances of decreasing the demand 50%, chances of increasing the price 50%, chances of decreasing the price 50%. So, again the transition probabilities are 0.25 for all these 4 states in period 2. So, I request my participants that for remaining 3 states of period 1, you can develop similar type of states for period 2. And when you develop states for these 3 states, the successive states, many of those states will be the common which you get here in this discussion. Like when the demand is 120, when the demand is 120, if it increases, it will increase by a factor of 20%, so 1.2, and then in that case it may become 144, demand may become 144. So many of those things are possible that where you have the common values in these final states. So I request all my participants that you please develop, and once you develop this entire tree, decision tree, so this is the representation of our various states, the transition probabilities, and now the evaluation of various alternatives, that these 3 alternatives which are there will start. So, but before that, please complete this decision tree, because this decision tree will help us, and I have this, please be careful in reading these values. These are 0.25, 0.25, 0.25 and 0.25. So slightly misadjusted values are there. So all these I have written very clearly on the board, that these are 0.25, 0.25, 0.25 as my transition probabilities. Similarly, in this case of period 2, this has 4 possibilities which are represented here, and from this also you have 4 different possibilities. From this state also you have 4 different possible states which are emerging, and from here also you have 4 different states which are emerging. And now you can see, and when you make your own decision tree diagram, you will see that many of these states are common. Many of these states are common. For example, if we talk of this state, D equals to 96 and price is 1.19, price is 1.19, this is common in almost, because you have one arrow coming from here, one arrow coming from here, one arrow coming from here, and one arrow coming from here. So this state is being represented by all the 4 states of the period 1. You can have possibility, so it is not exclusive 4, it is not exclusive 4 you are going to get from here. Your states will have various you can say common states in these 3 other calculations. So otherwise 4 into 4 you will have 16 unique states, but you will not have 16 unique states. You can just count that we have in period 2 1, 2, 3, 4, 5, 6, 7, 8, 9 unique states. So that is something we should understand, that and this is again rooted to our that type of discussion which we have in last to last session, where when I am talking of PU, when it can increase and it can decrease. So when PU decreases it becomes PUD, when PD increases it becomes PUD. So this state becomes common for both these previous states. This state becomes common for both these previous states. So same logic applies in this particular case also, that there are various common states, there are various common states in developing this decision tree. But developing this decision tree is a very good visual representation of our entire state of affairs which may be there in the future. Now let us start discussion on the evaluation of the alternatives, that how are we going to evaluate these alternatives, and for that purpose first we are going to analyze the option of not signing a lease and obtaining all warehouse space from the spot market. So, we are considering this option first, that I am going to take the entire space on the basis of a spot market. So, as we mentioned that we need to start from the last period. So, we will start with the period 2 and calculate the profit at each node. So, at this case, for D equals to 144 and price 1.45. So, this is probably this situation where 1.32 into 1.1, this is 1.45. So, I am starting with this particular state, and how we will go backward, that you will come to know. For that purpose, to determine the cost, here we will write it in such fashion: D 144, P is 1.45, comma 2. This comma 2 signifies that the time period, it is 2 now. It is 2 if I write comma 1. So, this is the state at period 1. So, D 144, P 1.45, this is the state, and comma 2, this is the time period. So, this is the situation, and what will be the cost, because the demand is 144 here. You see how do we calculate this? Demand is 144 and price is 1.45 square feet of space. So, and my company is committed to fulfill the entire demand. Whatever demand is there, I am going to fulfill that demand completely. So, I will multiply this price with this demand. So, and I have already mentioned that D is in 1000 units. So, this 144,000 into 1.45, this is the cost of the space. This is the cost of the space, and if I am having this much demand 144, so my revenue is, for this option, my revenue is, I will be selling because my revenue is 1.22 dollar per unit of the demand. So, I will multiply, because I am fulfilling this demand 144,000. So, 144,000 into 1.22, that is my revenue, and when I subtract cost from the revenue, so 144,000 into 1.22 minus this cost, that will become my profit. So, I am subtracting 144 minus this cost, and this is 175,680 minus 2,800, this is $33,120 negative. It means that if this is the situation, 144 is the demand and I am fulfilling the complete demand using the spot market, I will be charged at the rate of 1.45. My revenue is not going to change whether I am using spot market or lease. So, my customer is not worried about that. So, I will get the fixed amount of revenue on at the rate of 1.22. So, the simple logic is that my revenue is 1.44 into 1.22, that is the revenue which I am going to get. Revenue minus cost, cost is 144 into 1.45, that is my cost. So, this is the profit. So, 144 is common. So, you can say that this is minus 0.23. So, this multiplication yields me $33,120. So, it is a loss. It is a loss. So, I will evaluate all possibilities of such, and we'll develop a tabular kind of arrangement, and then we'll see that which option is better. So, we stop here. We understood the method of calculation, but we stop here today, and in our next session we will develop the tables, and then we will evaluate, we will compare the three alternatives which are available to our warehousing company. Thank you very much.